Hello and welcome to this presentation on multivariate data. I am Garvit Bagdia and today we will explore what multivariate data is, why it matters and how it is used in real-world analysis across industries. So let's get started. In this session, we aim to understand the core concept of multivariate data, identify different types of variables you might encounter. Let's learn ways to visualize and summarize this data, explore key analysis techniques like PCA, clustering, and regression, and finally see how multivariate data is applied in real-world contexts. Here's the roadmap of today's talk. We will begin with the basic introduction, move through types of variables and data compressions, learn about visualization, summary statistics, dimensionality reduction, clustering, classification, and then wrap up with application, benefits, limitations, and key takeaways. Multivariate data simply refers to data involving more than two variables per observation. It's commonly seen in fields like finance, biology, marketing, and the social sciences. These kind of data helps us to capture the complexity of real-world scenarios, allowing for deeper insight and improved predictive analysis. Now we are going to learn about the types of variables. There are different types of variables. Firstly, quantitative variables. These are the numerical values that can be measured. There are two types of quantitative variables. First one is discrete, which is countable values. Example, the number of children's test scores, etc. Another type is continuous quantitative variables, which means measurable on scale. For example, height, temperature, etc. Some of the uses are it is actually used in operations like calculating averages, standard deviation, and regression. Another type of variable is categorical variable. Variable that represent categories or groups. For example, gender, male or female, country, blood type, etc. There are some of the characteristics like it cannot perform mathematical operations directly, often used in classification types. Some of the coding tip is need to be encoded, for example before feeding into machine learning modules. Another type is ordinal variables. Ordinal variables are actually the categorical variables with an inherent order. For example, educational level, high school, bachelor's, master's. Customer satisfaction means low to high, etc. Some of the importance is while they have an order, the intervals between categories are not uniform. Now we are going to move forward with the mixed data variables. Data sets that includes a combination of numeric and categorical variables are known as mixed variables. For example, a data set with age, which is actually quantitative, gender, which is categorical, and satisfaction level is basically ordinal. The relevance is actually the common in real world data sets require hybrid handling during analysis. Now we are moving forward uh, to the types of data like multivariate data, univariate data, and bivariate data. Univariate data basically focus on the single variable. On the other hand, bivariate data deals with two variables and typically looks at their relationships. Multivariate data is, however, involves three or more variables and can uncover complex interactions like simpler method might miss. If we move forward to the classification of universal data, let's talk about some of the examples first. Like univariate data, just tracking height of the students, we can use univariate analysis. Bivariate analysis we can use as height versus weight, price versus quantity or quality. And multivariate analysis we can say age, income, educational level, and spending score for each customer. Now we are moving towards the visualization techniques. The first one is scatter plot matrix. Firstly, what it is actually? A grid of a scatter plate showing pairwise relationship between variables. The use is quick insight into correlations and clustering. The example we can take is comparing height versus weight versus age, etc. Another one is heat maps. Heat maps, a color coded matrix that shows the correlation or distance between the variables. One of the uses quickly shows which variables are strongly or weakly related. One tip is actually used alongside correlation coefficient for deeper analysis. Another type is a parallel coordinates plot. Each variable is an axis and each observation is a line that crosses each axis at appropriate value. The use is detect cluster or trends across many dimensions, and the challenges can be cluttered with large data sets but great for medium sized multivariate data. Another type is PCA plot. PCA stands for Principal Component Analysis. So what it is actually? Projects high dimensional data onto 2 or 3 components that explain most of the variance. The use is great for visualizing hidden patterns on grouping in high dimensional data. One pro tip is helps before applying machine learning to reduce noise and improve the performance. Now we are going to learn about the summary statistics. When analyzing multivariate data, we use mean, median, and mode for each variable, covariance and correlation matrices to see how variables relate, multivariate normal distribution for modeling, and box plots to visualize the spread and outliners basically. Now we are going to learn about the dimensionality reduction. One of the example is PCA that we have seen in the previous slides. So dimensionality reduction is basically as data set grows in complexity, we need ways to simplify one common method, which is principal component analysis. Basically, it reduces data to 2 to 3 components while preserving variance. It is helpful in visualization, noise filtering, and speeding up models. Another is clustering and classification. So classification is basically next look how do we group and categorize the cluster. Basically clustering find natural groupings in data like k-means. Classification predicts the categories using methods like decision tree, logistic regression. And another one is decrement analysis. Decrement analysis is basically used for separate predefined groups. Now to understand all the concepts we can take one of the numerical example for better understanding. Now let's bring this to life with a simple example. Imagine we are analyzing the student performance like student, age, test score, study hours and attendance. Let's take a single student A who has an age 18, test score 85, study hours is 5 and attendance is 92%. So each row is a student, each column is a variable. With this, we can calculate the correlations like study hours versus test scores, detect patterns such as whether better attendance lead to higher performance. We can use clustering to group the similar students, or we can build a model to predict the scores. Right. Now we are moving forward towards the application of multivariate data. So multivariate data is used in marketing for customer segmentation, healthcare we all know for diagnosis, finance for risk assessment, environmental science to track the multiple climate variables, image processing for extracting the features, education to predict the student performance, and even transportation also for optimizing the routes based on multiple factors. There and now we are going to understand some of the advantages like multivariate data is helps in captures complex relationships. It also enables better predictions. It also serve as a base for machine learning, and it also leads to the richer insights and supports the interaction analysis across multiple variables. But there are some limitations also, like it's harder to visualize, risk for multi-collinearity, overfitting in models, can be complex to interpret, sensitive to scaling, and noise in one variable may affect the entire analysis. Now, to handle those limitations, you can use dimensionality reduction, standardize or normalize variables, do feature selection, leverage domain expertise, use smart distance matrices like Mahalanobis, and always validate your models with cross validation. Now, to conclude, the multivariate data involves multiple variables per observation, and it also enables the deep insights and supports machine learning. The key tools includes visualization, PCA, clustering, regression. It is widely used and incredibly powerful for real-world applications also. Thank you for watching this session on multivariate data. I hope this gave you a strong foundation in understanding and applying multivariate analysis. Now feel free to reach out with questions. Thank you.